lesson review 18 is about continuity, and we've touched on this a little bit on some things, but now we're just focusing on it. Gotta remember the definition of continuity, okay? You have to prove that the point exists, that the limit exists, and that the limit equals what the point equals. So you're filling in a hole, basically, with this example. So let's see. If I were to draw a picture of a graph, and you're saying the limit from the left is equal to the limit from the right, okay? And so we'll just call that, C. This is A. And so, okay, so the limit from the left equals the limit from the right. Therefore, the limit as x goes to A exists because the left side and the right side. So sometimes you have to talk about the left, that it exists from the left and it equals the limit that exists from the right. So therefore, the limit exists. We're going to say it's equal to C. And then also, we have to have this filled in, meaning that f of A equals C. So you would say equals f of A. So that's what this continuity, the three things that have to be continuous, and it's like really has to be known for the test. Pretty much assured they're going to ask about continuity somewhere. Now, it's discontinuous, the function, if it has at least one point where the conditions aren't satisfied. And we have kinds of discontinuity. We have removable, which is like a hole. And we have infinite, which is with asymptotes. And we have jump. So we have three kinds of discontinuity. So remember those three and what it entails. We'll do some examples of those. And then a function is continuous over the interval, not just at a point, if it's continuous at every point in the interval. Okay, so that's something sometimes you have to prove it's continuous by saying that that it's continuous over an interval. Now, we have certain theorems of discontinuity. So if you have two continuous functions, f and g, you can add them, subtract them, multiply them, divide them, so as long as g is not equal to 0 when you divide them. So you can do all those things with continuous function, and that makes it a continuous function. So sometimes they'll give you like a squared plus 2 over a minus 2, and it's going to be continuous if this is continuous. Now, this isn't continuous, so it has to be both top and bottom continuous. Remember that a polynomial function is continuous everywhere, so every polynomial, and that's nice to know. A rational function, a fraction function, is continuous everywhere except where the denominator is 0, so those are your vertical asymptotes, right? And then we have to remember that this is where the intermediate value theorem comes in, and you have the cheat sheet on that. And this is also Rolle's theorem, this one down here. So remember, it says that if it's continuous, there has to be every y has to be used, basically. So go look over that intermediate value theorem. And then the special case of the intermediate value theorem, it says that, and we'll go over this on an example, if you have a closed interval and you take a function and one of them has opposite sign from the other, if you take it at two places, then it has to have a 0 in between them, because you can't go, if you're down here, this is A and this is B, and the function is down here, and it's negative at A. See how it's negative? F of A is less than 0, and f of b is greater than 0, so there has to be a 0 in between there. And that's really Rolle's, but don't say Rolle's on the AP exam. It's just, you're showing off. Just say intermediate value theorem, because it's a special case of the intermediate value theorem. All right, so that was your first kind of overview, and we'll the next videos will cover the examples.